Hey guys, this is the fourth video in chapter 2, naming polyatomic ions in compounds, or naming compounds containing polyatomic ions. Now it's actually pretty easy. Once you get the actual polyatomic ions down, naming the compounds is a piece of cake. So how do we name polyatomic compounds containing polyatomic ions? Well, it's a little different than binary ionic compounds in that all we have to do is name the metal and then the polyatomic ion, because the polyatomic ion already tells us how many oxygens there are and it differentiates between things. So all we have to do is name them. So if we look at our last video, we can see that SO4 would be sulfate, so SO3 must be sulfite, so this guy is sulfite, and this is of course magnesium. And so the name here is magnesium sulfite. That's it. You're done. All you have to know is the polyatomic ion, and you get the name down pretty easily. What about this guy? Well, this is sodium, and this is phosphate. Sorry about the misspelling there. But yeah, sodium phosphate, not too bad. And then MnO4 is one you had to remember, and this is potassium permanganate. So again, you just name the metal and then the polyatomic ion, and that's about it for naming polyatomic ions. It's going to take some practice before you get all the naming down, but once you do, it's pretty simple stuff. What about going from the formula to the name? Or from the name to the formula. Sorry, we just went from the formula to the name. What about from the name to the formula? Well, going from the name to the formula is actually pretty analogous to binary ionic compounds in that we do the little switcheroo thing, but there's one little difference. Here we've got aluminum, and from one of the first videos we know aluminum is a 3+, and here we've got carbonate, and that is CO3 2-. Gonna have to memorize, or not memorize, we're gonna have to figure out how to get carbonate. Now, once we do that, we can do our little switcheroo thing. The difference here is this 3. Now, aluminum is of course 2, but the 3 has to go outside of parentheses because what we're saying is that we need 3 individual carbonate polyatomic ions. So none of this, like don't do this jazz, or don't do something like that multiplied by 3. Those are wrong. You need to put parentheses and put that 3 outside of it when you have multiple polyatomic ions. It's just like S3 or P3 or anything, any element 3, but we have more than one element there, so we have to block it off in brackets and say, okay, we need 3 individual carbonate ions. The next one is strontium nitrite. Strontium, Sr2+, nitrite, nitrate's NO3, so nitrite must be NO2, and if you remember, Nick the camel has one vowel, so that's NO2-. Do the little switcheroo thing again. We've got Sr, and then we've got NO2, and we've got 2 of those guys, so that's pretty nice. Barium sulfate. We've got barium, which is a 2+, and we've got sulfate. Remember from supper from Nick the camel, SO4 2-, 2 vowels there in supper. So then we can do our little switcheroo thing, and we would get Ba2SO42, but remember, just like binary ionic compounds, we have to make sure they're the lowest value they can be. We can divide both these by 2, so they just cancel each other out, right? The 2+ and 2- just cancel each other out. Barium sulfate. So that's important there. Just like binary ionic compounds that we talked about in the second video, we have to deal with transition metals once again. So let's do a couple of examples of those. Here we've got iron 2. So that tells us it's a 2+, and chlorate tells us it's CO3-. Remember, chlorate from clams, 3 different consonants and 1 vowel, and so then we can do our little switch thing to figure out the subscripts. So we've got Fe, and we're going to have parentheses, ClO3, and 2 of those guys. Not too bad. What about the names? Well, here we've got chromium, and OH is one you had to remember, and that was hydroxide. Hydroxide. Now to figure out the charge, remember we have to have Roman numerals for transition metals. To figure out the charge, we have to do kind of what we did before. And I'm just going to rewrite it up here, CrOH3. Each hydroxide is a negative charge. It's one of those you have to memorize. So we've got 3 of these guys. And so chromium has to be a 3+ to make this a 0, right? Because all compounds here have to equal 0. So this has to be a 3+ and a 3- gives us a neutral compound. So this guy has to be chromium 3. Here we go with nickel. Nickel something, and NO3, remember from Nick the Camel, is nitrate. Each nitrate carries a negative charge with it, which gives us a 2- charge total from the nitrates, right? So that means nickel has to be a 2+, must be a 2+ to make sure this compound's neutral, and that gives us nickel 2 nitrate. Okay, another example, copper 1 phosphate. Copper with a positive charge, phosphate, PO4 3-. Do our little switch thing. And we've got copper and 3 of those, I don't know why I rewrote it, sorry. Copper, and then we've got phosphate, Cu3 PO4. We don't need parentheses this time because we've got 1 phosphate there. So only use parentheses whenever you have more than 1. That's important because I see people, write it, write something like this. And that's wrong. You don't need these parentheses here. Just write it without. Cu3PO4. Okay. Finally, I just want to kind of point out this ammonium compound. So we don't have a metal this time, but we do have a cation. And so we name the cation and then the polyatomic ion. Our cation in this case is ammonium. And then our polyatomic ion as the anion is carbonate. So we just name the 2, ammonium carbonate. Now, the reason why I really wanted to point this out is ammonium is a cation. It takes the place of a metal in an ionic compound. So even though this is a nonmetal and this is a nonmetal and this is and this and this is, we don't have any metals in there, it's still an ionic compound. Ammonium is a cation, and so if it's involved, it's still an ionic compound. So don't get that confused on a test or something like that, because inevitably it's on there, and people choose that it's a covalent compound because it doesn't have any metals with it. So that's a brief review on how to name polyatomic ions, compounds containing polyatomic ions, and hopefully with some practice you'll be good to go on that. The next video is acids and covalent compounds, where we'll learn how to name acids and covalent compounds.